All right, here's example 3.3 from OpenStax PreCalculus. I wanted to talk through example 3.3 because I think that your book is 100% right, not to disparage your book in any way. I think there's an easier way to think about that than this. You're adding 3 minus 4i and 2 plus 5i. Sure, you could say that playing the role of A is a 3, playing the role of B is -4, playing the role of C is 2, and playing the role of D is 5, and then memorize that the way you add numbers up is A plus C. Well, I said A was 3 and C was 2, and 3 plus 2 is 5. So here's the 3 plus 2 and the 5. And then to that I want to add whatever B and D are and go through the problem that way. You could do that, but you really don't need to memorize any of this. You can tackle this problem if you just treat I like X. What? Well, you're probably pretty good at doing algebra, and if I say what is 3 minus 4x plus 2 plus 5x, you can combine like terms here. Right? You can say, well, the 3 and the 2 gives me the 5, and the -4x plus the 5x gives me -1x. In other words, I got 5 minus x. And if these were x's, you could deal with them. And the nice thing about complex numbers is the reason this notation is chosen is so that they act like these guys do. So really, when you're adding complex numbers, all you got to do is pretend the i's are x's. So if you gave me 3 minus 4i plus 2 plus 5i, and some people like to have these parentheses around here. Note that the parentheses aren't really doing anything, but with the parentheses around it, it makes it, you treat this like this is one number, because it really is one number. It's one complex number. I know it looks like two different numbers. 3 is one of them, and then minus this other number, 4i. But it's not. You'll think about this whole thing as one number. It's just the notation we choose, 3 minus 4i, is very suggestive in that it's written in a way where if you treated it like two different numbers, the algebra would still all work out fine. So 3 plus 2 would give me 5. How about this? Using the commutative property, I can change the order these things are written in. Okay, this is overkill. And then combining like terms, I get 5 minus I. Anyways, the point that I want to make, which I probably could have made in 15 seconds and instead made in 115 seconds, is that anytime you're adding or subtracting complex numbers, all you got to do is treat the i's like the x's. That's it. Treat i's as though they were x's. Think about what you would do in that situation.